So how can we create a binary image from a grayscale or full color image so that we can separate objects or foreground pixel from background pixel to aid in image processing? Folks, Nitin here, and this is the AI University channel. In this video, I'm going to explain the OpenCV concepts like binarization or thresholding, etc. As well as going to show you the OpenCV implementation of all these concepts using various threshold methods. So watch this video till the end. If you are new here, then consider subscribing to this channel, or if you have already subscribed, then click on the bell icon to receive the notifications about hottest technologies of 21st century. Please show your love and support by liking, sharing and subscribing to this video, as I will feel highly motivated. You can share it even with your colleagues and friends. Also, we now have the AI University Android app and the website, which is in beta mode right now. You can download the code related Jupyter notebooks by enrolling to this course right here on the AI University website. All the courses are offered for free on the website, and you can access the related quizzes and a certificate of course completion like this from the AI University once I upload all the videos and once you complete all the tutorials including final quiz. Image thresholding concepts are heavily used in computer vision related applications or products, so it is going to be key to understand these concepts. So what is image thresholding or binarization? Well, it is a way to create a binary image from a grayscale or full color image. This is typically done in order to separate objects or foreground pixels from background pixels to aid in image processing. We use a OpenCV function called threshold to convert an image into binary form. Please note that the threshold function use grayscale images before it do thresholding, so you need to convert your color image into grayscale if you have one. If you want to know how can you convert an image from color to grayscale, then you can watch this video, link of which is given in the I button above. Now this function takes several arguments, and number one argument is input image on which we want to apply a thresholding. Second argument is threshold value, which is used to classify the pixel values. Third argument is maximum value, which is assigned to pixel values exceeding the threshold. And fourth argument is threshold type, which provides different type of thresholding methods. Some of these threshold types are threshold binary, threshold fine binary inverse, threshold trunk, threshold to 0 and threshold to 0 inverse. I'm not going to go in details of each of these threshold types, but if you want to know more about them, then you can go through this link. Now consider this grayscale image here, which has 8-bit pixel values ranging from 0 to 255. We are, let's say, setting the threshold value to 127, which is a middle value between 0 and 255. We are going to set the maximum value, which is assigned to pixel values exceeding the threshold. That is, any value above 127 will be set as 255. Anything below 127 will be set as 0. So the third argument, which is a max value, will be set as 255. We will be using various threshold types to explain the concepts. So let's head over to the Jupyter notebook. So you can see we are first importing our familiar CV2 and NumPy modules. In the next line, we are reading our image using imRead function, giving the path of image as an argument and storing it in a variable called as image data underscore original in order to show you the original image. In the next line, we are using OpenCV's threshold function to convert image to binary form. First argument to this function is input image. Second argument is threshold value. Third argument is maximum value. Fourth argument is threshold type, which in this case we are setting as threshold binary. Then in the next line, we are showcasing the binary image output of threshold binary type. We have similar kind of code in the next set of lines, with the only difference of various threshold types, because we wanted to see the output binary images of all the threshold types. So now let me run this cell. So when I ran the cell, several binary images got generated. So if you can see on the top left corner, this is our original image. So in case of threshold binary, which is this one, anything below 127 is set as black and anything above 127 is set as white. In case of threshold binary inverse, you can see that it did the opposite of threshold binary. That is, it set the values below 127 as white and anything above 127 is set as black. So just opposite of threshold binary. In case of threshold trunk, anything above 127, that is brighter shades or shades with range 128 to 255, are set as 127, which is a shade of gray, and kept anything below 127 as it is. Then we have this threshold to 0 image. So in case of threshold to 0, anything below 127, that is little darker shades or shades with range 0 to 126, are set as 0, which is shade of black, and keeps anything above 127 as it is. Finally, we have threshold to 0 inverse, which is the inverse of threshold to 0, and where anything above 127 is set as 0, which is shade of black, and anything below 127 is kept as it is. Now there is a drawback associated with the threshold functions or algorithms, and which is setting up this maximum value 127, or as a matter of fact any other value for this parameter. That is quite problematic when you are analyzing let's say any scanned document. So to cater such problems, we use another type of thresholding technique called as adaptive threshold. Adaptive or local adaptive thresholding algorithm changes the threshold dynamically over the image. It chooses different threshold values for every pixel in the image based on the analysis of its neighboring pixel. This is to allow images with varying contrast levels where a thresholding technique will not work satisfactorily. There are various adaptive threshold algorithms such as adaptive thresh mean C, thresh Otsu, and adaptive thresh Gaussian C, which are available in OpenCV. Now explaining each one of them is out of the scope of this video. So now let's see how can we implement the adaptive threshold, and then we will compare different images. So here I'm reading an image which is nothing but a scanned document. In the next line I'm applying regular threshold on this image where the threshold value is set as 127. Hopefully this code looks familiar to you as we have already covered previously. So now let me run this cell. So this is how my original image looks like. Then I'm blurring an image before applying adaptive threshold as it's a good practice because it removes unnecessary noise. Then I'm applying adaptive threshold on this blurred image, and this function is adaptive threshold. Now in order to blur the image we used Gaussian blur. Okay, and this blurring techniques I have already covered in a separate video, so you can click on the I button above to know more about Gaussian blur and other blurring techniques. So this adaptive threshold function right here, it has several parameters like input image, then the maximum value which is kept as 255, adaptive type which is kept as adaptive threshold mean C. This adaptive type is actually based on the mean of the neighbor of the pixel. Threshold type which we kept as thresh binary, and block size we kept as 3, and this is essentially needs to be the odd number, and then we have a constant value 5 which is going to be subtracted from mean, and you can change this number and see if you get any optimum result. So now let me run this cell. So when I run this cell, you can see the image which is the original image we had, and then you have this image where the adaptive thresholding has been applied. You can see the text is more prominent here. So adaptive threshold changed the threshold dynamically over the image. It has chosen different threshold values for every pixel in the image based on the analysis of its neighboring pixel, thereby doing better job here. So folks, this is it for this video. In the next upcoming video, I will cover another important topic of the computer vision using OpenCV series. So here is today's question, straight true or false. One of the threshold type in OpenCV thresholding is thrash underscore bin. Please post your answers, comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also post your technical questions in the comment section and I will try to answer the same. If you are watching this video and you are not already a subscriber to our channel, consider clicking that little subscribe button. In case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me guys. I will be covering next topic in the upcoming video, so keep on watching. Thank you.